Professor Worgley's here. Today we're going to go over lecture 17, Model View Controller. This is starting a new content series, getting ready for the next challenge. So far, we've been building FXML applications. We haven't taken a look at that third component, which is the model. We're going to take a look at that today. So come over here to lecture 17, download the slides. Also download the code example and get that loaded into NetBeans. So far with every application we've made, what we've done is we've just created an FXML file and an associated controller, which is good. It's good to have that code separation, but to implement MVC, we need to implement that last third component. Okay, and let's talk about what MVC is, Model View Controller. So you can open up the PDF, take some notes. You're going to see MVC on quizzes. You're going to see them on the midterm. You're going to see it on the final. You're going to see it everywhere. So MVC is very important. I only have a few slides here, but there's a good article to read where I get all of my quiz questions. Yeah, I actually have the link. Is it here? I don't have it here. It's on Canvas. It will be shared, but I can share it now. If you just search Java Oracle Model View Controller, there's one document you got to read. It's got images. Okay, it's got images. Let's see if these images work. No images here. Let me search this title real quick. You can search this title. Java SE application design with MVC. Here's the one with pictures. So this is the article, and I'll put this in the chat if you'd like to bookmark it, where probably 80 to 90% of the quiz questions are going to be coming from for the next. Whenever you get the MVC quiz, the link I just posted in the chat will be 80 to 90% of the answers. They have nice diagrams here, which explain the original MVC design. Then they show different versions of the MVC design. And then they show the modified version of the MVC design, which is the one that most everybody uses today. They may say Java Swing here. We're using JavaFX. So even though they have some different elements here, that's okay. You can still get the idea. They even show coding examples, which this abstract model here in code sample 2 will actually be code that we're going to copy and paste into our projects for the next challenge. So this will be a document that you will be referencing in your code if you implement that challenge correctly, because everybody will need this abstract class. Coming back to the slides, let's just talk about what MVC is. So MVC is actually a design pattern. In this class, we're going to be learning a lot of design patterns. If you ever go to the Google interview, they're going to ask you design patterns. They want to know, do you know how to build code correctly? Do you know how to organize code in such a fashion that's going to be able to handle billions of users, just like Google has to handle every single day? So in order to do that, you need to implement the MVC architecture. It's going to be everywhere. Let's say you don't even go to a company like Google. You go to a local company. You need to know MVC. Everybody's implementing MVC. So I can hire, let's say I have my own business, so I can hire a front-end developer. I can hire a back-end developer. I can hire a database administrator. And all those three different roles are not conflicting with each other. If you want to implement that, you need to implement MVC. So if you ever look for a job application and you're applying online, you'll see they do have front-end developers. They do have back-end developers. They do have database administrators. In order to accomplish this, you need to implement MVC. So MVC is the model, the view, and the controller. There are three roles. We've already seen some of these roles with our FXML file. Okay, that's going to be one of the roles, which is going to be the view, which is the user interface. So this design pattern defines the way objects communicate with each other. Remember what objects are? Those are classes. Okay, so you can kind of intermix those two words, although we do know the difference between them. So as well as the roles they play, as well as the roles these objects play in the application. By adopting this pattern, there are numerous benefits. Okay, objects tend to be more reusable, interfaces tend to be better defined, apps are more easily extensible, and essentially you can separate the application concerns, the different types of developers, and then everybody can work on their own document without conflicts when you merge back up to your GitHub branch. So here's what it looks like. Okay, we have our model, we have our view, we have our controller. So this is the modified version. I really recommend you go and read that doc. Okay, it's very important that you read that doc, the Oracle doc that I sent there in the chat. So let's say here I have my view. Okay, this is going to be my user interface. Here I'm going to have buttons. I'm going to have a text object. I'm going to have my stopwatch. Okay, so we have our stopwatch example. We have the analog display. Maybe I can even write on here a little bit to make it easier to see. Okay, so we have our, I don't know if you can see this. Here's a clock. Okay, there's our analog clock. We had some buttons down below. This is our UI. We had our start button. So the user clicks the start button. When the user clicks the start button, that goes to the controller and triggers an event listener. Remember, all the event listeners have @FXML. Okay, they have @FXML, and then down below they have public void start. Okay, we can just call it start. That controller start method will then go to the model and tell the model, let's say timeline. Okay, let's say there's a timeline over here. Timeline, keyframe, all that stuff we set up, tells the timeline to go ahead and start. As the timeline's updating its values, okay, they're going to notify the controller. See this arrow here? I'm going to notify the controller with the updates. Okay, so in the controller here, you're going to have some method. Maybe you're going to have it called update analog. Okay, update analog. You have some method there that updates the display. Update analog will then set the rotation, set rotate to whatever was passed from the model. Okay, it's going to pass whatever was from the model, and then it's going to update the UI. Okay, so then user clicks stop. That goes over here to an event listener. The controller has a stop method that tells the model, hey, stop the timeline. Model says, okay, I've stopped the timeline. And now the controller then stops the UI. User clicks start button again, comes over here, tells the controller, hey, start back up from its original position. Model says, okay, start the timeline. Timeline's running, it's shooting back all the values. That will tell the controller to set the rotation on the analog display. Okay, so I have all three different components here. You have the model, the view, and the controller. And this is the way that it's going to be set up to have this perfect design. So what's the point of the model? Let's go over each component. You kind of get the basic idea. The model encapsulates the data. So the model will be the data of the application. Now, what students usually get wrong is they just put the data there. So they'll just put a timeline and they'll just put a keyframe. And when they start that timeline and keyframe, it'll actually be over there in the controller. That's not true. You'll see here it also defines the logic and computation that manipulates and processes the data. So not only does it define the data, it also defines the methods that manipulate the data. Okay, so this is a very key, important fact that most students tend to get wrong come midterm exam, come the challenge when they implement it. What's nice about this separation is I can have a one-to-one or one-to-many relationship with other models. So by me separating the data out into its own model, let's say I have an analog display and I have a digital display. I can have several models here because they're all independent of each other. And that's what's so beautiful about the MVC design pattern. I can have one view, go into one controller, go into one model. Hopefully you can see the whiteboard here. Let me know if you can't. I can have two views. I can have two views. Okay, these are all views. Maybe two views go to one controller. Okay, two views go to one controller. Something happened with my jaw here. Two views go to one controller. And then maybe this one controller handles two models. So each component is independent of each other, which makes the design pattern so beautiful. I can have just one-to-one. I can have one-to-many. I can have several controllers here. Okay, I can have each controller goes to each view goes to its own controller, which goes to its own model. Or I can have several views go to one controller, which go to one model. Or I can have 7 views go to one controller that goes to several models. They're all just independent of each other. Let's see, are each component of the MVC in 3 separate classes? That's correct. You will have 3 separate classes, and that's a good way to look at it to make it easy to define in your mind. The view will be the FXML file. The controller we've seen already. We put everything in the controller so far, but now we're going to separate it out. We'll have a separate Java file which holds our data and our methods that manipulate the data. Okay, so the model usually is the state data of the application. Is the user logged in? What's their login info? What's their username? What's their age? What post did they post on Facebook? How many people liked that post? Okay, all this information will be in the model. Model objects usually represent knowledge or expertise of the specific domain. Model should have no explicit connection to the view. That's the number one thing. So if I go back to this graph, you'll see the view goes to the controller goes to the model goes back to the controller, and then controller updates the view. You'll see the model does not update the view directly. There's no arrow here. And a lot of students tend to get this wrong when they're implementing the challenge. They'll just have the model update the view directly. This is not correct. There is no arrow here. The model does not update the view directly. There should be no view elements in here. So in your model, if you ever see something like, oh, I have a text area in here, that's wrong. Or maybe I have text area set text. I'm setting the text. I'm updating the UI. These are all bad things. The model should never update the view directly, and it should never have any view objects in there. It should only have data objects. Okay, let's talk about the, one last thing about the model. The model should have no concern of the user interface issues either. So the view should never talk to the model either. So if I click a button and that button needs to update data, the model shouldn't handle that. So the model shouldn't talk to the view, and the view shouldn't talk to the model. That's why we call the controller the middleman. The controller needs to handle both user actions and data updates. Okay, so that's why we call it the middleman. All interactions from the view to the model always go through the controller. But the golden thing to remember here on an exam is the model represents the data. Okay, model represents the data, and the model should never talk to the view directly. Those are the 2 most important things. Let's look at the view. So the view is your FXML file. It usually is what the user can see and what the user can respond to. So when I click on a button, that button's going to be in the view. And when I click on that button, it goes to an event listener in the controller. So not only will the view handle user actions or can respond to them, it'll also display the data from the model and usually will allow editing of that data. So let's say I go to Facebook, I log in, controller says, hey, check this user. Model says, yep, their username and password's correct. Controller says, okay, go to the home page. Now I'm at the home page. The view says, hey, I need the post. controller says, okay, model, give me all the posts. Model says, here's the post. And then the controller shows all the user's posts on the view. And then they can edit those posts or like those posts or dislike those posts. They'll like the post. They'll come to the controller. Controller says, the view says, hey, controller, the user disliked this post. The controller will go over to the model. Model says, hey, decrease the number of likes and increase the number of dislikes, or however the system's implemented. Controller says, model will say, okay, controller, I have that done. Controller will then update the view. Okay, so you'll see these objects are typically decoupled. They're completely independent of each other. Again, the controller is the middleman. Okay, it handles actions between one or more view objects. It also handles actions between one or more model objects. Let's see, Olivia, are you required to have a model? If you're implementing MVC, then yes, you need a model. Now, right now, you're working on the current challenge CPU monitor. For this challenge, you do not need a model. If you were to implement a model, you'd get bonus points for it, but that's not a requirement for the current challenge. But if you're implementing the MVC design pattern, you have to have all three. Okay, you have to have all three of these. Otherwise, you're not implementing the MVC design pattern properly. Would a database be a good example of a model? That's correct. A database is a great example of a model. Normally here, the model is a Java file, and this Java file will connect to the database. So if I had a database, this would still be a .java file. It would connect to the database. It would do queries. So it'd say select star. From post, it would say select user from the user database. Give me the username and password. And then it'll check the password. If it's correct, then notify the controller. API is another good example. This would still be a .java file, but this Java file would connect to the API. It would get the data, parse the data, and then it would return the data to be displayed to the controller. So this model will always be a .java file. It just depends on what this model is connected to, and that may be why you have multiple models. Maybe you're using Facebook. This model connects to the database. The other model connects to an API to tell them some other information. So you may have a database, you may have an API, but this will still be a .java file. It just connects to those things. Let's see. So what would be an example of a model if you weren't using an API or a database? I can have variables here. I can have a username variable set. I can have a password variable set. So I can still have the variables set in the .java file. Maybe I have an array list of all the users, and every user has a username and password. And every time I load the application, maybe I load it from a file. Or maybe every time I load the application, it doesn't store the data. Maybe it's a game. And every time you start the game up, you have to start back from level 1. We'll actually take a look at the example without using a database or an API today. So since the controller is acting from the view and the model, that's why we call it the middleman. Okay, that's why we call it the middleman. It performs setup and coordinates the task for the app and manages the life cycles of other objects. So it creates the model object, and then it handles the life cycle for the model. Okay, talking about communication, the same type of principle. The user actions are usually in the view. Then the user clicks on a button, it goes to the controller. Then the controller creates or updates the model object. When the model object changes, it notifies the controller, which then updates the view. So it's the kind of a similar example as I was talking about earlier. Let's see. Okay, so you just use it to store data, but not necessarily in a database or API. So you could use MVC if you're creating an application that stores data. That's correct. even if it's not connecting to a database or an API. Maybe I have the data stored locally in the application, maybe in some variables or some uh, array list, maybe some different type of collections, maybe a hash map. I have a address book, or maybe a classroom log system. Every time I run the file, run the program, I have the user select a file, and it will load the previous class notes into the model. That way I can see them, edit them, and then when I close the app, it then writes deletes the old file and writes a new one. That way I can store some information there. So it doesn't have to be complicated. It can be very simple. And you don't even have to write to a file. Maybe you start the app up every time and it's a new information. That wouldn't be a good user experience. But just for a basic MVC, you could not have a database and not have an API and still have the MVC design pattern. Let's see. I think we talked about communication. We kind of talked about an example with Facebook. You can go through this example. It's an address book. We're actually going to take a look at the address book. So for example, let's say I have a view. I want to add a user. That comes over here to the controller. Controller says, hey, model, I want to add this user that the view gave me. We give that, pass that data to the model. The model puts it into the array list or whatever data you're using. And then the model says, hey, I've added the user. Controller then updates the view and say, user added successfully, or there was an error adding this user. Then they say, okay, I want to delete the user. Controller says, hey, delete user this. Model says, okay, I've deleted it. And then the controller says, user deleted successfully, or was not able to delete user for this reason. Okay, so you'll see the model will have a list of people. Could be an array list, could be a linked list, whatever you want to implement. The interface will display the list of people in its view FXML file, and the controller handles actions between the UI and the model, such as add person or delete person. To be fully MVC, the model should know nothing about the view. The controller handles both changing the model and updating the view, and the view tells the controller about user actions. So they're basically all independent of each other. And the model will never talk to the view directly. So I didn't say, oh, click the start button. Controller tells the timeline to start, and then the timeline updates the view. The timeline would then pass the values back to the controller, and then the controller would update the view. That's the proper MVC design pattern. So in short, you'll see here the model is the data, the view is the UI, the controller is the middleman. You'll see I kind of repeat myself several times here. The model is the data, the view is the UI, the interface, the controller is the middleman. It's important to remember that. You'll definitely want to read a lot of documentation. I got a lot of docs. You got Apple docs, tutorials point. Google has a good doc about model view controller. The Google is a good one that I use for my web course. So if I search Google's MVC design pattern, they have one for Chrome developers. And if you read this, you'll see it has the same design pattern that I just got done talking about. It's just in a different programming language. The one for the quiz is right here. If you read this doc and read the slides and have a basic understanding of the code, you will do well on the quiz. Most of the content's up here. It talks about the old pattern and the new pattern. Let's take a look at some code. Go back to lecture 17 and download this zip file, MVC example.zip. Let's actually implement it so we can see how each component plays with each other. So we have the model, the view, and the controller. The view is the UI, the model is the middleman, and then, the controller is the middleman, and the model is the data. So here you're going to see 4 files. If you implement MVC properly, especially in JavaFX or FXML, there's going to be 4 files. First file you're going to have is the main. Okay, remember the main, there's no purpose here. All it does is loads the FXML file, sets up the scene, and then shows the scene on the stage, sets the scene on the stage, and then shows the stage. So there's a purpose here, but there's no coding purpose here. The purpose of the main class in a JavaFX program or an FXML program is just to get the scene prepared. Okay, so here I'm loading the FXML file. It's going to create all the objects with FX IDs, set the scene, and then combine it to the stage. That's the whole purpose of the main class in an FXML application, or as well as the JavaFX application. There may have been a few coding challenges. I said do everything in the main, but that's not normally a common practice. I just wanted you to get familiar with JavaFX and FXML. But this is a standard main class with FXML. Now you're going to see all the logic code is moved to the controller. So I have my view. If I open up my view, okay, so if you double click, it'll open up in Scene Builder. It's just a basic view. I just want you to get a basic understanding of MVC. If I right click, you'll see it has an FX ID. This is not required on the root, although it is there quite often. If I scroll over to the right, you'll see it has an FX controller. Okay, this is important. You got to have this FX controller, and it needs to be case sensitive as the controller in the application. Otherwise, it's not going to run. So open up the view. You'll see I have it here. It's very simple. I have a menu button. I can add a person. I can delete everybody, and I can get everybody. So we're just going to keep it simple, although you could definitely add a lot more functionality. So in order they click add user on the view, it's going to come over here to the controller. You'll see in the controller, I have my add FXML variables. These are all my FX IDs. In order for these FX IDs to work, you need the add FXML annotation, and these need to be case sensitive the same. They're not case sensitive the same as the FX IDs, the code won't work. You'll see the controller also implements initializable. This is important. That way you can have your initialize method. The purpose of the initialize method will be to create the model object. Okay, it will be to create the model object. And then you'll see I have my event listeners. Add person, get everyone, delete everyone. But you're not going to see any data here. For this class, and it's probably different in the industry because in Google you have billions of users, so you may have several models here. But in this class, we usually only have one or two models, and those will be the only fields that are not at FXML. Everything else will be at FXML. You'll not have any variables like counter here. You won't have lap count here. You won't have the timeline here. You won't have any of those variables here. Those are going to be all in the model. So let's start with the model and put all of our data here. So remember, the model is the data and the methods that manipulate the data. And then the controller is just the middleman. So let's assume here I have an array list. So I want to use data encapsulation. I'm going to make it private. So I'm going to create an array list of strings. I'm going to create an array list of strings. I could also create my own people object. Maybe a person has a first name, a last name, an address, who knows, a bunch of different information. So I could create a person object here, or people, and I could create my own class and have those variables there. I could store that here. But for now, let's just keep it simple. We'll just do a string. We'll just store their name. Okay, and I'll have an array called people. You'll usually have a constructor here. So this is a normal Java class. In fact, the model will be the most normal class that you're going to see from what we were implementing earlier. So for the first few weeks, we were talking about just Java in general and just basic OOP. The model will look exactly like the classes that we implemented at the beginning of the semester. So you use data encapsulation, you'll have your constructors. The constructor will use for initialization of the data. And then you'll have your methods, your getters and your setters. Your getters and your setters will be called from the controller and returned to the controller. So right now, let's say if I create a model object, I'll just create a new people array each time. So I'll create a new array list. On this side, you only need to do the diamond notation. We'll talk about this later as we talk about collections more. Just for now, just write this down. Later, I'll talk about why we use the diamond annotation here. And then we can have some methods here. So I can say, okay, public void add people. And people is going to take a string, which is going to be a person. And I'm basically just going to add it to the array list. So I'll say, take my people array list. And they have a method here called add. We'll talk about these methods later. And I'm going to add person to it. And person will just be their name. It could be their first name, first and last name. Doesn't matter in this example. We're mainly focused on MVC. Notice how the methods are public. So I'm doing data encapsulation. Okay, so here I'll do public void get everyone. Okay, I could do get one particular person, or I could do get these people in a range. We can implement a lot here, but for now, I'm just going to return the entire array list. Keep it simple. If I do a get, I need to have a return value. So I could either say get person or get everyone. If I get everyone, I need to return the array list, which is of type string. Last method we'll create today is going to be delete everyone. Okay, delete everyone. And if I do my people array and then do the dot notation, they actually have methods that I could use. So I could use the clear method. If I look at clear, it says remove all elements from the list. The list will be empty after this call returns. That's perfect. I don't want a new list. I just want it to be empty. So I could do clear. A lot of students will do people equals void or null. Yes, this could work. It could delete the array list, use the garbage collector. This is usually not a common practice to do. This is a better approach. If I did this in a Google interview, it would work, but you normally use the clear method. You normally use methods defined with those collections. We'll talk about collections more here in a little bit. Okay, that's an important concept for the Google interview. Let's see. Do you need to take in the array list as a parameter? Let's see. At this time, I don't. It's going to be the global array list. Let's say I had a bunch of different people list, then I would. Then I could say, okay, tell me which list you want to delete, and then I'll delete that particular one. For this case, we only have one, so we're going to use the global list. But if I had a bunch of different lists, then I would need to determine which one to delete. Okay, good question, Austin. So this is just my basic model. Now, this is a very small model. Okay, I could have people, I could have addresses, I could have the relationships of each person, who's their friends, what's their post. There could be a lot of information here, but we're just going to keep it simple here at first. Let's see. So is that case the same for the add people method? Add people, I'm going to actually add a particular person here. Delete everybody will clear the entire list. I could add another method that said delete this one particular person. If I want to delete that one person, then yes, I need a parameter, and I'd say people.remove, and then whatever person you're trying to remove. I just want to keep it simple here. Delete everybody. It's a little bit easier. I don't need to pass anything. We could add a bunch of methods. We could add people. We could add a group of people. We could get everyone, or we could get a particular person. We could delete everyone or delete a particular person. But let's just keep it simple for now. So now this is it. This is your model. It's the data and the methods that manipulate the data. Manipulation occurs usually in a database. We call it CRUD, CRUD. Some people call it CRUD. I call it CRUD. It's create. Okay, so here I'm creating data. And then you have updating data. I really don't have updating data here, but if we had update person, we could. And then you have read. So that's going to be our get. And then you have your delete. So you have create, read, update, which we don't have, and delete. So these are your basic CRUD operations, which whenever I say manipulate the data, that's what I mean, basic CRUD operations. We also have the constructor creating the people array list. This is perfect. This is where it should be. You'll see a lot of students do this in an interview. They'll put it up here, and that's okay. It works. But usually you don't want this array list to be created until they actually create the object for the model. So you tend to put the object creation here. That's a better implementation than putting it globally. If I put it globally, then it'll be created when I click play. And that's going to be a waste of memory. And memory is a big deal at Google when you have billions of users. So you don't want to use memory when you don't need to. So here's my model. That's good enough for now. Let's go over here to the controller. So the first thing you need in the controller is you need to connect the controller and the model. So you actually create the model here. So I'll say MVC example. I'm going to call it model. That's this is the type. This is the name. So that's why I'm going to call it model. So it's really easy. We only have one. Again, I could initialize the model here. I could say new MVC model, but that's not a good practice. You want to do it in the constructor. The constructor for the controller is your initialize method. So here I'm going to say model equals new MVC example model. Now in this case, we only have one controller. So this is almost the same as putting it up at the top. Once I click play, this initialize method is going to run. So they're basically the same, but let's assume I had several controllers with several models. I may not want to create certain models until I need them. We call that lazy loading, and that's a good thing to save space. So now that the model is created, you'll see the model is the only not at FXML variable. This is correct. If you see yourself here having an int for the time elapsed, and then you have another int for the lap count, and then you have another int for delta, angle delta per seconds, this is not correct. The only not at FXML variable you should have is the model. And if you do, then you know you're implementing it correctly. Now, how are we going to do this? So if I want to add a person, the controller is just the middleman. It says model, add person. And where are we going to get this person? Okay, so the person is going to come from the UI. So I'll say, okay, and maybe we should do an if here. Maybe we should check. That way we can give the users some information. So if the text field, dot get text is not empty, I hope you are using the methods on your challenges. If you weren't, make sure you start using them for now. A lot of students will do, okay, get the text as long as the text doesn't equal null. This is not correct. Or they'll say get the length as long as the length is greater than 0. That's better than the double equals, but you should use the is empty method. This is even better. So if it's not empty, okay, if it's not empty, then we're going to go ahead and try to add this person. Okay, then we're going to go try to add this person. How do I add the person? As long as the text field's not empty, then I'm going to go ahead and get the text and add that to the array. Add that to the array list. Okay, how do I get everybody? Okay, how do I get everybody? So here I'm going to grab the text field. I can call the model. If I want to get everybody, I'll call the get everyone method. It returns an array list. Okay, so I could store it as a variable, or I could just basically turn it into a string and just show it right on the text area. So I can say text area dot set text with model dot get everyone, which turns an array list, and I'll just call it toString. It's not going to look the prettiest. Probably should loop through the array list and format every object, but let's keep it simple. And if I want to delete everybody, maybe I could have a message. I could say, are you sure you want to delete everybody? And if that pops up as yes, then I delete. For now, we'll just keep it simple. I'll call model.delete. And you'll see that's it. When you implement MVC, the controller is short. All it does is creates the model and then talks to the model, communicates to the model, tells the model what to do. The model returns back the data and then updates the UI. Okay, it updates the UI. So it has the add FXML variables, which are your FX IDs. It has your handle event listeners, which are your add FXML methods. And then it'll initialize the model object. And then it'll call the models, tell it to update the data, and then it'll also come back and update the views. So let's run this. And you'll see how short the code is. Look how beautiful and clean this code is. They say code is like an art. So the more beautiful and clean your code is, the more beautiful this art is, so to speak, for a developer. They have the art of the code. Look how clean this is. It's so short. It's so simple. I don't even need to write notes. Whenever I click the add person button, I'm telling the model to add that person. Okay, so it's so self-explanatory. So let's see if this works. So I'm going to do add person. You'll see there's nothing there. So if I do get everyone, it's empty. If I actually type somebody there, let's say Nick, and then I do add person. Okay, you're not going to see anything yet, but if I do get everybody, you'll see it was in the array list. So now I can put Susan, click add, click get. You'll see Susan was added. I added Susan again. Okay, now if I do delete and then do a get, you'll see it was successfully deleted. Okay, so everything's working properly. I have my view, which is the UI. I have my controller, which is the middleman. And I have my model, which is the data and the methods that manipulate the data. I'm actually going to write that down because you're going to see that everywhere. And a lot of students forget. So it's the model is equal to the data, but also the methods that manipulate the data. Okay, and that's basically your crude operations. But we have a problem here. Okay, we have a problem here. Let's see. Whenever I try to run my code, a box pops up saying available classes with nothing available. Make sure you open up MVC. Make sure you click on a class here, and then make sure you run. Make sure all of the files are saved. If you're still having issues after you click and they're all saved, close NetBeans out, maybe come back into it. You don't have to worry about running it right now. Maybe just collect the notes for now, and then we can try to fix it up here in a second after the lecture. I don't want you to close NetBeans and you miss a bunch of notes. But now we have a problem here. We didn't implement MVC truly. For example, when I add person, it comes over here and updates the model. But look at this. We never got this back arrow here. The model never said, hey, I added that person, and the controller never updated the view. What a horrible experience. In order for me to know if that person added, I had to go and click get everyone to see if it actually added that person. The most common mistake, which is why I implemented this way, is students forget these two arrows. And these are big points here. They always forget these two arrows here. Okay, these are big points on the challenge. If you forget these two arrows, you're going to receive a hefty deduction, especially since I'm going over this. Right now, we don't have these two arrows. Now, let's say when I do get everyone, I click get everyone. That comes over here to the controller. Controller says, hey, model, give me everybody. Model returns the array list, and then the controller does update the view. So for get everybody, I have the complete cycle here. Okay, I have the complete cycle here. But for the other two, I do not. For add person and delete person, the only way to know is to actually click get everybody. So this MVC is a fail case of MVC. Okay, this is an incorrect case of MVC. Let me clear this out. So let's go back to the code. How can we fix this up? One of the most simplest ways is having a return value here. If I look at this add method, if I do a show Java doc, let's see, it's going to open up over here. That's okay. I'll bring it over. If I look at the add method, look at this. It returns a Boolean. And the return method says it returns true if it was added to the collection correctly. So I can do something like this, change this to Boolean, add person, and I could say, okay, if add person was true, return true, otherwise return false. Or I could shorten up the code even more, just say return add person. So whenever I try to add the person to the array list, this returns a Boolean value, whether it was true or false, and then I'll have that as my return type. Okay, so the code is nice and short. If you implemented it this way, if add person or even add person is equal to true, and then you did a return in a Google interview, return true, and then you did an else like this, you don't have to write this because it's not the final one. And then if you did a return false here, you could still pass. There's nothing wrong with this. It's just more code than you need to write. If I just do return people, so I'll actually leave this here in the code, these are actually equivalent. If I just do return people.add, since add already returns a Boolean, add already has these if statements. If I was able to add it, return true. If I wasn't able to add it, return false. These already exist in this method. So these two are equivalent. This one already returns something. So this one was implemented properly. What about clear? So if I right click on clear, do a show Java doc, you'll see it returns void. So I can't use the clear. It returns void, but if I scroll up, you'll see here I have an is empty, which returns a Boolean value, which returns true if the list contains no elements. So again, I could do another if after the clear, if people is empty, or I can shorten it up and just return is people if it's empty or not. If it's empty, it's going to return true. Otherwise, it's going to return false. Make sure you change these return types on the methods. So now I have that two-way communication with every method. So every method that the controller asks the model to do, you need two-way communication. You need two-way communication. The view tells the controller to update. The controller tells the model to update. Then the model has to notify the controller, and then the controller has to update the UI. If you don't, it's a horrible user experience if you forget this arrow, because now I have to click get everybody to know if it worked or not. Okay, so you need the two-way communication. That's the most important thing on MVC, and it's the one that students forget the most. So if I come back over here to the controller, okay, now we're actually returning something. So I just have another if here. So I'd say if it's empty, I could come back and I can say text area, set text. I can say, please type a person, give them some error messages. Users love error messages, otherwise they don't know what's going on. And I can say if add person is equal to true, instead of having to get everyone to determine, I can say text area, set text, add person successfully. I can even get the name that they typed. And say, I added this person successfully. Get everyone already updated the view, so it's fine. But I'd have an if here. If delete everyone returns true, then I'd say text area dot set text, delete everyone was successful. Okay, if it returned false, I would have an if else, and then I'd say on the text area, maybe was not able to delete everyone. And then I could display some error message. Was not able to delete everyone. And I could tell them why. If I knew why, I would tell them why. So if I run this, okay, I know we're out of time. Let me just run this. We'll collect the attendance. So now I'll put in Nick, click add. You'll see I got a message back. That's nice. I could also clear this text field for them automatically. Now if I add Susan, okay, click it again. You'll see add person successfully. It'd be nice if it said added Susan successfully. That'd be even better. If I do a get everyone, you'll see I see Nick and Susan. If I do a delete, now you'll see delete everyone was successful. So now I have some feedback. What a much better user experience. But the only way to do that is I need the two-way communication. View tells the controller what to do. Controller updates the model. Model notifies the controller. Don't forget this arrow. And then the controller updates the view. You got to do that on every action. If you don't have both arrows, MVC is not implemented correctly. Okay, that's it. Now we're out of time for today. Put your name and pop it in on the chat. This is the basic MVC design pattern in a very simple example. Next class, we're going to take a look at it using a real life example. We're going to implement the stopwatch challenge using MVC. Okay, so we'll actually implement something that's very useful for your challenge. We'll do stopwatch. We'll take a look at some bugs that are most commonly implemented by students. And then I'll show you how to fix those bugs. Okay, I'll show you how to fix those bugs. So next class, we'll take a look. You'll have probably 60% of the knowledge. And then by Friday, you should have 90 to 95% of the knowledge that you will need to complete the next challenge. Okay, so put your name and pop it on the chat. I will have my office hours later on today. So if you have any questions, you can stop by. I'm sure there'll be a lot of people there today, but I'll help as many students as I can. Also, get the challenge done. Okay, get the challenge done. We have office hours today and tomorrow. We are looking at emails over the weekend. We're answering emails today, any emails that we may have missed late last night. But stop by office hours if you need any help. That should be it. Get the challenge and the quiz done. I won't post the next challenge until we finish this one. So I'll probably post the next challenge on Wednesday, maybe Tuesday night, to give some people a head start if they're waiting on the next challenge. Thank you, Andy. Okay, that's it for today. Put your name and pop it on the chat. I'll be here for a few minutes. I got another meeting coming up here at noon, but I have a few minutes if you have any questions. Otherwise, we will see you next time.